All right, in this video, we're going to take a look at evaluating piecewise defined functions. So piecewise defined functions are going to take pieces and parts of other functions and then kind of put them together like in Frankenstein or Frankenstein, if you're a Mel Brooks fan. So we have a function that's composed of other functions, and we restrict the domain of those functions and graph what we have for that part of the function. So here we have, pardon me, a sine function, which we'll worry about later. We have a x squared minus 3. We have negative 8x plus 30. And over here we have the domain restrictions for each of these. So if our values of x are between negative 9 and negative 2, we're going to plug them into this first function here. This one with the sine. If our values of x are between negative 2 and 3, we're going to plug them into this second function here, the x squared minus 3. And if our values of x are between 3 and 4.5, we're going to plug them into this third function, negative 8x plus 30. So here's what the graph of that piecewise function looks like. So over here we have the first function, that sine function. Notice we have between negative 2 and negative 9 here. Actually, this arrowhead shouldn't be here. It should just be a solid point. And between negative 2 and 3, we have x squared minus 3. So can equal negative 2 for this second one. So that's why we have a closed circle here for the x squared minus 3, but not the closed circle for the sine one from the top of that piecewise function. And then we have negative 8x plus 30 when x is between 3 and 4.5. So again, this shouldn't be an error. It should just be a point, a solid point. But we're taking pieces and parts of other functions, just putting them together to make a piecewise defined function. So when evaluating piecewise defined functions, pay attention to the domain of each piece. And your domain of each piece is listed over here to the right. Excuse me. So if our values, when we plug in a function, we evaluate this function for a value of x, we have to see which of these domains we got to plug it into. So the value of x is only going to be in one of these three domains, and we can have as many as we like. We could have a piecewise function that has thousands of pieces to it. But the important part is when we evaluate a function, a piecewise function, we have to know which of these conditions we have to plug it into. So it's kind of like conditional statements in computer science. So example 5 here, we have a little bit of a simpler piecewise function. We have 4 minus x squared when x is less than 1, and x minus 3 when x is greater than or equal to 1. And in my Desmos tutorial playlist, I have a video on how to put in piecewise functions into Desmos, so you can actually see a visualization of something like this. But for our purposes here, we're going to evaluate f of negative 3. So looking at these domains, which domain is negative 3 going to be in? Is negative 3 less than 1, or is negative 3 greater than or equal to 1? Well, negative 3 is less than 1, so we're going to plug a negative 3 in for this first function. So 4 minus negative 3 squared gives us negative 5. Part B, f of 0. So once again, 0 is less than 1, so we're going to plug 0 into this first function. We get 4 minus 0 squared, which is just 4. Part C, f of 2. Well, this time, 2 is not less than 1. 2 is greater than 1. So if it's greater than or equal to 1, we're plugging it into this second equation. So 2 minus 3, that gives us negative 1. And then 3 halves. 3 halves is bigger than 1, so we're going to plug it into this second equation. 3 halves minus 3 is negative 3 halves. So 1.5 minus 3 is negative 1.5, or negative 3 halves. So that about does it for this video. Thanks for watching, and I'll see you next time.